think we might just be a continuation video from L3V4 where we determine the stability for a particular output k-1 and k-2. If you still remember in that particular video, if you haven't watched it, I just suggest you just watch that particular video, alright, on L3V4, alright, in this playlist. Okay, so I assume that you already watched that. Alright, is that this U k-1 and U k-2 is talking about the output, only two outputs. Think about it. You have a multiple sampled signal, alright, these are all discrete signal, alright, and this is k-1 and k-2, alright. So UK is equals to this thing, alright. So this whole chunk over here is talking only about these 3 points, and if you were to find stability for these 3 points, you are only finding stability within this particular system only, alright. You are not finding stability throughout the whole digital domain. The whole digital domain, alright, talks about other points, talks about this point, this point, this point, this point, all the way to infinity. Alright, so all the way there is all the hell of the signals. Wherever the signals comes from your analog, you will just take all the digital points. So this whole digital points, if you sum it all together, it must be Beebo stable. Okay. So therefore, this thing that this orange dragon that orange line that I've drawn is a Beebo system. Is a summation of all your signals. Alright, and it must be Beebo stable. Alright, if you think about it, in the previous video we talk about summations, alright, where your h, your transfer function, must be smaller than in infinity, right? Something like that. So this is the thing. So you summation all your stuff, okay? While this portion over here talks about only these 3 points. You see? So if you were to look at a very long chunk of signal, alright, that spans all the way, happen if I go like this, alright, this black color signal, this 3 points over here is just mild, right? It's just 3 points only, nothing much. Alright, so the stability, although this is stable, although later on we will prove that it is stable, but at the end of the day, it may not be stable throughout this whole orange line if you sum all of them together. Alright, and therefore do not be confused that, alright, this thing over here is stable means everything is stable. Alright, so therefore what we are going to do right now is to prove to you that it will be stable for all of the digital signal. Okay, so you think about it, this is 0.5 UK if I were to remove everything. Yep. So if this thing over here we have proved to you in the L3V4 video, correct? And now we're going to prove to you that for all of the signals, it will be a Beebo stable. Okay, so in fact, you see the coefficients are the same, while these are the same, but the UK-2 and EK is different already. So this thing over here, we can use this information to help us to find our Beebo stability. So if happen that if you are given only this type of answer or question, alright, and they ask you to find the stability of this thing, and then they ask you whether is this thing Beebo stable or not. So the first thing, so you in order to calculate stability, you first calculate the stability as what we have calculated from L3V4. Okay, then next there is a Beebo stability. Alright, so what we are calculating now is actually calculating stability for these 3 points only. Right, these 3 points only. Alright, well, what we are going to calculate next, well, that we are doing soon, coming up, is going to calculate all the signal as I keep on repeating, right? Because I just want to inform you that. So if happen you will have this thing, you need to find the stability of this, okay? And then you also need to find the Beebo stability. So you change your UK-2 and you change it to EK, and that's it. Then you calculate this thing, alright? And this is what we are doing right now. Okay, so far so good. So therefore, let's just continue now. Let's calculate this Beebo stability. Okay, in fact, we have only one step. Alright, this is a shortcut. Alright, then later on I will use another video to prove to you how the shortcut comes in. Alright, in order to keep it sweet. Alright, so in order to do this, I'll just call this A0 and I'll just call this B0. Alright, the equation is just, alright, I should say that this is the B0 is this thing, minus 0.3. So in other words, alright, what you're looking at is something like this, alright, plus. Okay, so 0.5 UK minus 1 plus minus 0.3 EK. Alright, so your summation is your B0. Alright, is it B0? Sorry. Summation A0 K, alright, minus, sorry, not minus, but just B0. So your general equation is this form. That's all. And I should call this a A1. Alright, this is the rule lah, but no need to care about the subscript, but I just want to be clear about this. Okay, so what we have is just sub in A1. A1 is 0.5, so summation is 0.5 K. Alright, while your this thing B0 is just your minus 0.3, so I have minus 0.3 over here, and that's all. Alright, and then next I'll just write K. If you remember, this thing over here is your geometric series. Alright, so we can rewrite, imagine your geometric series is AK is equals to 1 over 1 minus A. Tiobo. So therefore what I'm doing now, same thing. Alright, I'll just rewrite as minus 0.3. Alright, this thing over here I'll just rewrite as 1 over 1 minus 0.5. Okay, and that's all. Alright, and as long as your this value, alright, this value must be smaller, alright, your A1 must be smaller than 1 in order to be stable. And that's all it is. Let's just do another question. I'll just copy the thing. If I were to bring this down, paste it over here, just put it slightly smaller. Okay, next same thing. I see that there is a negative sign. By right it should be positive. Alright, so I should write it as plus. Okay, so plus minus EK. Okay, and therefore I'll just call this, alright, my A1. Alright, and I'll just call this B0. Right, minus 1, right? Minus 1 times EK is minus EK. Alright, so I'll just sub in this thing. I'll just have minus 1 summation A1 is 1.6 K. And then I know that this is geometric series. I'll have minus 1 over 1 minus 1.6. And in fact my 1.6 is larger than 1, right? So therefore this is BIBO unstable. Okay, so previously when we do the other one, when we do this one, alright, you see that this is actually a BIBO stable, right? And therefore it's stable lah. Alright, so therefore whenever you need to know whether is it BIBO stable or not, the first thing first is to look at the first value, A1. If it's smaller than 1, alright, it's stable. If it's larger than 1, then it's not stable. That's the thing that I can conclude from there. Alright, and same thing over here. This is your A1. This is your B0, right? So same thing. I'll have my B0 summation A1K. I would have B0 is 0.4. Summation A1 is 0.8. So 0.8K. And then if I were to just rewrite this thing as a geometric series, I'll have 1 minus 0.8. Okay, and therefore this 0.8 is smaller than 1, so therefore it is also stable. Okay, if you don't believe me, this is the thing that is written from the textbook. Alright, A1 must be larger than 1. Alright, I mean smaller than 1, sorry. Alright, so therefore over here, as you can see, your A1 is smaller than 1. So as far as your A1 is smaller than 1, you should be BIBO stable. Right, this is the definitions, the condition for BIBO stability. Okay, so if you think about it, your 1.6 over here is larger, so therefore it's just unstable. Alright, and you may wonder next, this question. Alright, if you still remember, there is a summation of a student. Alright, over here we have this thing, UK minus 1 and UK minus 2. And we say that in order to find the stability, I'll remove the UK minus 2 as EK. And then we'll compute, right? Eventually we compute that actually the stability is 1 minus 0.8, then multiplied by 0.4. So 0.8 is, as long as 0.8 is smaller than 1, is stable. But however over here it writes as unstable. Alright, so by right we should be BIBO stable. So there is a contradicting thing right now. Over here the lecturer write unstable, But over here, from the textbook, where's my textbook? Yeah, from the textbook, A1, as long as A1 is smaller than 1, the condition for reverse stability is that. So you think about it, and I think we should follow the one in the textbook rather than the one from this thing, okay? Because maybe it's some class mistake, I think. But anyway, I'll leave you to this. So in the next video, we'll talk about how all this somewhat the so-called this condition has come about. If you are keen to learn, if you don't, then you just happy birthday. Yeah, see you.